This is Cognee's own code base, and this one line is what protects it against a path injection attack. Now, an AI assistant is about to remove it. Nobody told it why it was there and what it does. Let's see what happens. 400 milliseconds. That's all it took. Before any test, any code review. That's lore.
That warning just caught the exact kind of failure that has caused the world real damage. In 2006, OpenSSH shipped a one-line security fix. In 2020, a cleanup emerged. Test still passed, no one remembers why it was there. In 2024, it came back as a regression. This has been running on a 14 million servers for 4 years without anyone's knowledge. Every one of this has the exact same root cause. The code was reviewed, but the reason behind it was lost. That's what lore protects. Now let's see it in action.
It basically joins a base path with a file name and returns it. But first, it resolves both paths and confirms that the result stays inside the base. Now, when I hover over it, I can see that lore has attached memory to it. We can read about in which commit this line was introduced and on what date. We can also read about the author who introduced this, so we can ask them if we are unsure of anything. And it also tells the exact thing that was changed in that particular commit related to this function. Okay, so now let's say I have some question that I want to ask about this particular file, and I can just go to lore and I can ask my question directly. Now, this is also doable with using similarity search using a vector database. But what makes lore different is that we have introduced Cognee in its backend. So Cognee, here you can see the answer. So Cognee walked from the file to the decision to the commit and to the author who made it. 4 hops across a graph. Now, the knowledge graph can do this, but a similarity search cannot join all of these things. That's why Cognee was the best choice for this particular use case. Now, suppose a developer is reviewing this code and thinks that these lines they are just overhead for it, and they decide to clean it up. So let's just delete it. And when we go back to the home, we can see that there's a regression risk in the file. And there's also a red line here. When I hover over it, I can read the exact reason of this regression and why it is marking it as a regression. I can also ask Lore to help me fix this. So yeah, so it's giving me the answer of how to fix this. And if I just wanted to fix it for me, I can press here and yeah, so it was fixed. Okay, but this is not the only thing. Lore not only protects the old code, but it also scans new code as it comes in. So normally this is done at the commit step, but if you want, you can check any file by simply clicking this button. So review this file. So I'll show you the demo. Let's create a new file. Yeah. And I want to see if this file is conflicting with any of my old code or not. So I can simply go here and click on this button, and we can see the lore is reviewing against past decisions. Okay, so it shows that there is no conflict and no missing card in this file. And now, if we want to add this file to the memory, we can just click on here, and then lore will try to figure out what this card is doing and pre-fill the answer for us. We can, if we want, we can edit this, and if not, we can just press enter. And yeah, you can see that lore remembered this, so this was added to the memory on its own. So now let's have a look at the knowledge graph. So yeah, since we are currently in the validate.py, it opened it at hit validate, and yeah, if we open some other file which has a lot more commits than validate.py, then we can see all of these commits related to this particular file. And if we click on a particular commit, we can read about the author, the particular files that it touched, and if there is an advisory on the record or not. Now, if I want to know that what will happen if I remove this, it will tell me the exact code that will revert a past decision, and we can just, yeah, so we can check it this way. We can also see the whole graph, like all the files and all the modules here. You can click on any particular module and click on any particular file to know about its different commits. Okay, so now let's see how lore was actually built. The architecture is simple. One fast API service in Python with two front ends on top, a VS Code extension, and a web app. It reads your Git history into Cognee, whose graph vector memory links every decision to the code it governs, its authors, and the decisions before it. The live guardrail is deterministic Python, no LLM, so it is instant and reproducible on every keystroke. The model only powers the semantic layer. Ask why a line exists, and Cognee answers from that graph. So I think in 2026, with AI writing most of your diffs, lore becomes an even more useful tool to protect against such regressions and save a lot of time and money. And since this was made, like it has two front ends, right? A VS Code extension and a web app. The VS Code extension makes it very practical for the developers to actually use it and see the kind of changes that they make, which conflicts with older changes or older commits in real time. So thank you.